We are simulating the ultimate physics catastrophe. What exactly happens if our planet's rotation just stops? Now, this isn't just some wild sci-fi premise. It's actually a profound way to understand the invisible forces that govern our everyday existence.
Imagine waking up tomorrow and you find out the Earth has suddenly stopped spinning. There's no sunrise moving across the sky, no rotation beneath your feet, just stillness. At first glance, it might seem completely harmless, right? After all, we don't actually feel the spin as we're sitting here. But what would actually happen to the world around us in that exact moment of sudden stillness?
All right, here's our syllabus for today's chronological simulation. We'll start with the illusion of stillness, hit the terrifying first seconds of sudden deceleration, and then look at the great ocean migration. After that, we'll cover the months of fire and ice, the fading magnetic shield, and finally, human survival. It's a dramatic story that's going to unfold over several weeks.
So, part 1, the illusion of stillness and understanding planetary momentum. Because, believe it or not, right now, none of us are actually sitting still. Despite what your senses are telling you, if you're near the equator right now, you're moving at roughly 1,670 kilometers per hour. That's over 1,000 miles per hour. To put that in perspective, that is way faster than a commercial airplane. The only reason you don't feel this immense speed is because everything around you, the atmosphere, the oceans, this building, your own body, is moving at that exact same velocity.
Let's use a really simple analogy. Think about sitting inside a jet, cruising at altitude. You can sip your coffee, walk down the aisle, no problem, because you're moving with the plane. You only feel the motion if the pilot suddenly slams on the brakes. And that brings us right to Newton's first law, inertia. Objects in motion remain in motion unless acted upon by an external force. So if the Earth suddenly hit the brakes, everything on its surface would just keep moving.
Which leads us to section 2, the first terrifying seconds and the immediate consequences of that sudden deceleration.
Here's the absolutely crucial point. If the bedrock of our planet stopped instantly, the physics of inertia demand that anything not literally anchored into that bedrock becomes a deadly projectile. People, cars, buildings, even the oceans and the atmosphere, they'd all be hurled eastward at Earth's former rotational speed. Near the equator, you're looking at being swept away at over 1,000 miles per hour. Entire cities would be destroyed in literally seconds. Skyscrapers sheared right off their foundations.
And guys, it isn't just solid objects. The atmosphere rotates right along with the planet. If the ground stopped, the air keeps going, generating colossal 1,000 mile per hour winds. That easily dwarfs the strongest hurricanes humanity has ever recorded. The atmosphere itself turns into a global weapon, eroding mountains, ripping structures apart, and just completely flattening entire continents with flying debris.
Let's look at the timeline for this catastrophe. We just covered those violent first seconds, the deadly inertia projectiles. But as we transition into the days, weeks, and months post-event, we see a total collapse of Earth's life-sustaining systems. This is an escalating, dramatic story that gets so much worse long after the initial shaking stops.
Moving right along to section 3, the great ocean migration and reshaping the continents.
Now, what's fascinating here is the physics of Earth's shape. Over billions of years, the centrifugal force from our spin gave the Earth a slight outward bulge right at the equator. Our oceans have perfectly adjusted to that shape. But without that outward spin, gravity completely takes over. It pulls all that equatorial water straight toward the poles in a massive, civilization-ending migration. We'd see vast new equatorial landmasses emerge as the oceans drain away, while the polar regions would suffer permanent catastrophic flooding, totally erasing major cities off the map.
That brings us to section 4, months of fire and ice, and our global climate collapse.
Right now, Earth rotates once every 24 hours, giving us this nice, familiar, highly stabilizing day and night cycle. But without that rotation, a single day-night cycle would stretch out to last an entire year as the Earth slowly orbits the sun. Think about that. One hemisphere would face the sun continuously for months, becoming blisteringly, unlivably hot. The opposite side plunged into the dark void of space, dealing with unimaginably cold temperatures. This crazy contrast would spawn hyperviolent weather systems right at that boundary line between fire and ice.
And as we see here, the cascading biological effects of that extreme temperature shift are massive. Modern human civilization absolutely relies on predictable seasons and stable climates. Without the spin, familiar seasons change completely, and global rainfall patterns just collapse. Within weeks, we're looking at the rapid breakdown of global agriculture and food supply chains. Crops simply couldn't survive these new extremes, making huge agricultural regions completely uninhabitable.
Let's check out Section 5, the fading magnetic shield, and losing our solar protection.
So Earth's magnetic field is this absolutely crucial protective barrier. It's generated by a geodynamo effect, basically the complex movement of molten metal deep down in the planet's core, which is driven, you guessed it, in part by our rotation. If you alter those planetary dynamics and stop the spin, that molten core movement slows down. Over time, our invisible shield weakens. Eventually, this fading shield exposes the surface to deadly solar radiation, threatening whatever biological or technological life somehow managed to survive the winds and the climate collapse.
Finally, Section 6, the future of human survival. Can we adapt to a new planet?
Now, humans are remarkably adaptable. It's entirely possible a small population might actually survive this harsh new climate. But we'd have to completely abandon the surface. We're talking deep underground shelters, relying heavily on advanced tech to power artificial food systems and climate-controlled habitats. Make no mistake, class, the survivors would essentially be rebuilding human civilization on a totally alien world, far removed from the blue and green planet we know.
Now, before we wrap up today's simulation, there's a fascinating real-world truth I have to share with you. A very, very slow version of this deceleration is already happening to us right now, and it's being driven by the moon. The moon's gravity is actually acting like a giant brake on our planet through tidal friction.
Because of that lunar braking effect, every single century, Earth's day actually gets about 1.8 milliseconds longer. Literally, our planet is slowing down as we speak. Now, don't go rushing to build your underground bunkers just yet. This process is incredibly slow. We are talking billions of years before this slowing effect drastically changes our environment in any significant way.
I love this quote because it beautifully summarizes the science we've covered today. Rotation is the literal scientific foundation for modern human life. When we think about what keeps us alive, we usually think of water, air, maybe sunlight. But the spinning of our planet dictates everything from our weather to ocean currents, down to the very shape of our continents. It isn't just an astronomy detail, it is the invisible engine of our existence.
So, class, I leave you with this final, provocative thought for today's explainer video. If the very rotation beneath our feet is this massive, invisible engine keeping our civilization alive, what other hidden forces in the universe are we taking completely for granted? Keep questioning the world around you, and I'll see you in the next class.